What about dilutions? I love dilutions because it's M1V1 equals M2V2, or C1V1 equals C2V2. And it's just what you have and what you got, or what you have and what you're trying to get in a mass, molarity, concentration, whatever you want to call it, and volume in whichever volume you want. It doesn't have to be liters, but you know, if we're talking molarity, it should be. Okay, so this is why M1V1 equals M2V2 works, but we just know it works and we love it. We love it whenever we have something in a concentration, a molarity, an X, 10X concentration, 30% concentration, 30% solution, 2 molar, all of those, and we know a volume, and we either want a volume and that tells us the molarity, or we want a specific molarity and we have to come up with a volume. What do you mean by it? What do I mean? What do I mean? I mean this. And again, this worksheet was avoiding using X because people get scared of X, right? If you had a bad algebra experience, X might give you PTSD, and I don't blame you. So they just used a question mark because that's what we're trying to find. Okay, so if we want 1 liter of a mixed solution, so our final volume, 1 liter, and we wanted to both have sodium chloride and SDS. So again, we're doing that mix, all in the same thing. And we have a stock solution of each one. So we're not starting from powdered. Somebody made it for you. It's a 1 molar sodium chloride, or maybe you made it for the lab because you're awesome. And a 20% SDS stock. Maybe you made it, somebody else made it. But they're on the shelf. You're like, phew, don't have to weigh it out, don't have to do grams per mole, don't have to do any of that crap. We already have a concentration. So what we want to make is 1 liter of 10 millimolar sodium chloride, right? And we also want this same 1 liter to be 1% SDS. And we're starting with a 1 molar sodium chloride. So that's really 1 molar, right? Isn't 1 molar the same as 1,000 millimolar? Milli to molar, and then kilomolar, right? No? Nanomolar? Micromolar? Okay. 1,000 millimolar is 1 molar. And why did we change units? Because we want to carry the same units. If you don't have the same units on either side, you will not get the right answer. You will be off by many, many decimal points. So you either change this to molar and leave this as molar, or you change both to millimolar. You can't have 1 millimolar and 1 molar. Units must be the same. That's why I always say carry your units, and that's why I made such a big deal about it on the other calculations, because if you have 2 different units, they don't cancel unless you multiply or divide by 1,000. We're talking about metrics, right? 1,000? Whatever. Divide by whatever to make it, yeah, in this case it is 1,000. To make the units the same. If you forget that, you're going to be screwed. If you make your solutions wrong, your experiments will never work. You have to get this stuff right. Okay. And then our question mark is what volume of this 1,000 millimolar or the 1 molar stock solution? And then how much of this 20% stock solution, right, do you need to give you that 1%? And so they solved for question mark, and that's what they got. So let's do it instead of just showing it. So 1 liter times 10 millimolar equals X. So we could also, here, let's go back. Let's not do X. X is scary. We don't like X. So this could be B1, M1. Ooh, it's out of order. Doesn't matter, right? Because it's multiplying. And then B2, M2. Do we know the M2? Yeah. 1,000 millimolar. Right? 1 molar is what? 1 mole per liter. Okay. 1,000 millimolar, right? We want to make sure we keep our, whatever those are, units the same. Okay, so 1 times 10 is still 10, right? And this is millimolar liters equals V2, which is in liters, right, times the 1,000. Well, that we don't do anything, right? So how do we get rid of that 1,000 over there? Well, if we want to get rid of that 1,000, we can divide this side by 1,000 millimolars. And guess what? Millimolars cancel. So does the 1,000. 1,000 divided by 1,000 is 1. 1 times V2 is V2. But are we okay if we just do this? What did we say about equations? You have to do the same thing to the other side. So I'm going to do it to the one we already did the math for, right? So we could think about this is still V2 times 1, right? Because technically when we do this, it doesn't go away to nothing, right? It goes to 1. But multiplying anything by 1 is the anything. Sorry. Okay. So then if we divide this side by 1,000 millimolar, what happens? Millimolars go away, right? We get to cancel that. And 1 liter that we're left with divided by 100 millimolar, which is what? That is moles per milliliter. And that will give us either I don't have my calculator. I don't want to screw it up, right? Because we're in liters here, right? Remember I said we're in liters? So our answer is going to be in liters. And so if we do 1 divided by 100, is that, am I doing this right? 0.001? No, 001. 1, 2, 1, 2, 3. No, point. Move it over. Okay. See, I can't even remember the stupid decimals. I got it. I'm with the program now, people. 0.01 liters, right? And so if we multiply that by 1,000, how many mils are in a liter? 1,000. That guy times 1,000 milliliters equals 10 mLs. And that, my friends, is what they got up here. So what would I do? I would make this a little bit easier on myself. I would change my equation here. I would do, instead of saying 1 liter, because I don't want to do anything in the hell? Okay. There's a chicken scratch down there. I would change the liter to milliliters to start. So I would start with 1,000 ml times 10 millimolar, because now we're in milli equals, right, and then our V2 times 100 millimolar. And then when we do the math, right, V2 equals 10 mil. It's much easier that way than trying to convert it down here. Because what if you forgot? What if you've got that point? Yeah, I don't know why this is the 0.01. Why did that go there? What if you got the 0.01? Right, liters, and you just zoned out and thought that meant milliliters, and you put 0.01 milliliters in. You are not going to have the correct sodium chloride amount. Correct? Correct. All right, so let's try the SDS. let's get a new page. So we have, so what do we want? So it told us we wanted 1 liter. 1%? Is that what we wanted? Did it say 20%? Shit. I mean, shoot. Let's go look. Let's take a look at, yes. Okay. Okay, so 1 liter times 1% equals what? V2 times 20%. And again, we want it in mils, so let's change this already. And V2 is going to be in mils times 20%. And so what do we do? How do we get rid of that stuff? Divide both sides by 20%. Percents cancel. Divide both sides by 20%. Percents cancel. Percents cancel. 20s. This ends up being V2 in mils times 1 over 1,000 divided by 20. What's 1,000 divided by 20? 500? No. 50? 50? 50? 50? 50 times 20? Yeah. Yes? Yeah. 50 mLs. Okay, back. Woo! There we are, 50 mLs. So then what do? We have 10 mLs. Now you can hardly read this, right? Here we go. We have 10 mLs of our sodium chloride stock solution, and we have 50 mLs of our SDS stock, and then we bring it up to a liter. So what do? We take our graduated cylinder. There he is, right? And we put in our 50 mLs of our SDS solution, stock solution. We put in our 10 mLs of our sodium chloride, and then we fill the rest up with water to 1 liter. And then we mix. Yay, we did it. We did it, we did it, we did it. See, math is fun. It's like a puzzle. Okay, let's practice. Oh boy, here we go. We made 53.3 mil stock of a 1.5 molar solution of potassium chloride. Okay, so our stock solution is 1.5 molar, and we have 53.3 mils of it. So that's all we got, right? we want a 0.8 molar potassium chloride solution for the procedure. We are going to make 0.8 molar solution with this whole thing is what they're saying. So how much do you have to dilute if we're just going to use all of it and turn it into 0.8? What do we do? Okay, so we have 1.5 molar. We have 53.3 milliliters, 0.5 molar times V2. So what do we do? What? Oh, this is a typo. I'm like, what the hell? This is supposed to be 0.8. I'm like, good Lord, people. Times V2, right? I don't like the X because then it's confusing, right? We just use this. This is multiply, right? That's an 8. This is a 0. And we're not going to, because then that's confusing, right? Solving for X and there's all these stupid X's in there. And so what happens? This guy's showing us we're dividing both sides by 0.8 right here. We're going to get rid of that one again, right? So really it's V2 times 1, which is still V2. The 0.8 molar, whoops. And then this is, right, that's dividing the other side, right? The molars cancel, the 0.8s cancel, it's just 1. And then you do this math, which I'm not gonna do, but luckily, look, the molars cancel. What are we left with? Mils. Here's our answer. Voila. So now what do we need? We need to add, so how do you end up making this, right? This is just telling, so what is this number? This number is our final volume, right? I mean, this number is how much we need of, is that true? No, it is our, it's our final volume. So then we put that much into our 53.3 mils. Is that true? No. We want this to be our total volume. This guy to be our total volume. And so we already have this much. So how much do we add? Minus that is how much we add to the 53.3 mLs. Okay, does that make sense? Right, because this is our M1, V1, what we have, and then what we want. We want 0.8 molar. That's our final concentration. And so that would be in our final volume, not how much we add to the 53.53, but our final volume. And so then we have to take our answer. Our final volume is 99.938 mils. And so we have to add not that volume to our 53. We need to add 53.3 mils less than that so that our total ends up equaling this 99.938 mLs to get back to our total volume. If I had my calculator handy, I'd tell you what that is. 99 minus 53 is 46.6 or something, right? So we would add 46.6 something to this guy, and that would equal 99.9, our total volume. That makes sense? You can always do this backwards and see if you come back with 53.3. So you can take, now we have 8 molar, and we have 99, I'm just gonna do 99.9 for crap's sake. Here, let me change colors. Right, mils. And you can do, right, the V1, make this 1.5, and then solve for V1, better freaking get 53.3. Or I put in 53.3 here and then solve for molarity, better get 1.5. Then you know you did it right. I'm not doing it right now. But I should check myself in case this is all wrong. Just kidding, we're fine. Makes sense, yes? No. Okay, let's do another one. We're gonna do it with percents. Yay, percentages. Okay, our stock, 95%. Ethanol, that's the guy in the flammables cabinet. We want 25 mils of 20% ethanol solution. How do we make 25 mils of a 20% ethanol solution with that 95% ethanol? Well, here's what we have. We don't know how much of that do we need to make 20% in a total of 25. So this is just set up a little differently than the other one. This one's actually easier. That other example was a little bit harder. So let's see if this one helps you. If this one helps you, then you can go back to that other one. Right? Same old, same old. They're just not showing us all of the calculations. So this side, divide by 95%. This side, divide by 95%. Right? We cancel percents, we cancel 95. We have really V1 times 1. We do this math. What happens? The percents cancel and we're left with mLs, right? Ooh, that's nice. And if you do the math, I'm assuming they did the math correctly, our V1 is 5.62 mLs of this 95% solution. So 5.62 mLs of 95%, right? Plus how much water then? Well, if you want 25 mils and 5.26526 mils of it is ethanol, we want 19.74 mils of water. Or take our graduated cylinder. This guy's a smaller guy. Its total volume is 25 mils. We add our 5.265 of our 95%. Why do I keep saying 5.265? 5.26 mils, and then we add the rest up with water, and we don't need to do the math. Right? M1V1 equals M2V2. Carry your units. Make sure your units are equivalent. No liters and milliliters like that other one. Change them all at the beginning, or you have to remember to change them at the end. I would always change them over at the beginning because I would always forget to do it at the end and totally screw myself. So that's our little lesson. I hope I wasn't too confusing, but I hope showing you walking through these. I didn't do these ahead of time. I just winged it so that you could see where you might mess up and all the things you need to think about, right? If I had all it prepared, ready to go without any mistakes, then you'd be like, wow, that's so easy until you try to do it, right? So don't be scared and do a lot of practice. And just remember, math is fun. And calculations are fun, and that happy Foxtober.